Okay, so method overloading. So the name of a method and the types of its parameters are called method signature. So that means basically, um, everything like this. So the return type, the name of the variable, and the parameters. So that's called like the signature of the variable. So method overloading is basically allows you to create multiple methods with the same name, but having a different signature. So it isn't that each class must have a unique method names. Each class must have methods with unique signatures. So we can kind of see an example here. So these three methods are different methods, and they can be declared in the same class. So we'll go over classes at next time. So here we can kind of see that this void fill, and then it has, it returns nothing, a void returns nothing. It has, the method name of fill, and then it has two parameters that we use, and it's the data, which is, an array of ints, and the value, which is an int. And then we have another fill, which is a two-dimensional array, and then with another, two parameters, two-dimensional array and an int. And then we have another fill, which is a three-dimensional array and another value event. We also have an example of something that is the same signature but may look different. So the void returns nothing. The sum is the name, and then int x, y, x, is the parameters that go in. You may think it's different from having parameters with a different name, but it's not. Yes, it allows you to kind of, if you're working with, let's say, something like, if you ever have a one-dimensional array or a two-dimensional array, it basically allows you to kind of account for them both using the same name. So you don't have to come up with like another name. And this is something only, like I explained before, type languages have. Stuff like JavaScript and Python, which I don't know if you guys have used, but they're not a type language. So you can't actually have the same method or a method with the same name, but different variables. It's not going to work. So only type languages have this. So, going back to kind of this, this is the same exact method. I'll get back to that in 1 second, Carlos. Let me just finish this and I'll go back to define type languages. So this is the exact same thing because they have the same return type. They have, they have the same name. They have the same parameters input. So they have int and int, which is the same exact thing as this. So it's not really about how you name your variables in your parameters. It's, what type of parameter do you take in where, right? So something like this. So you can kind of Google this, but a typed language is basically in Java when you create a variable. For example, here, you give it the type. You give it like a function. You give it a type. When you give it a string, you give it a type, right? I can't do that, but a string, you give it a type. So every single thing that you basically do that requires you to set something to something. So an array, or sorry, not an array, a function can either return nothing or it returns something, right? So int is going to return you an int. With languages like JavaScript or Python, what they really do is have a function, give it a name, and then give it parameters, which are not typed either. So you give it like, array1, array2. So they're not typed. So nothing here, you don't even know if it's going to return anything, right? This is how it kind of works in Python and JavaScript, maybe some other languages I'm not naming. But these languages are not typed because there's no void function name, right? There's just a function name. That's how they work. And because of that, there's no typing. So you don't really know what this variable is. You can add some of the extra libraries to kind of to give it like a default or to tell what it's going to be. But the base language, if you don't add anything into it, no libraries, no nothing, or no imports, no anything like that, it's not a type language. And it's not a type language again because you can't specify the variable types. It's not something that's that you do in Python. Variables do have types, but they're defined at runtime. So when you're running your code, so you can do something like x is equal to 5. And then when you run your code, it's gonna know that x is a variable, and then later on you won't be able to do something like x is equal to 5. You won't be able to do this, but that's only for Python. I may be wrong though, but so that's how you basically define like type languages, where you have to define the variable types, the function types, the parameter types, and everything like that. So going back to method overloading, right? So let's say, for example, I may have actually variable referencing. That's good. And then we go, method overloading. Create another function here. And we'll take this. We'll go all the way to the bottom. And we'll pop this bad one here. So I don't want to return anything. This is my function. I don't want any parameters. And this is what I want, right? So method overloading. So I can have, if I call this, if I create public static void, I don't return anything, and then print array, my array. And then I do another one where public static void print array. And instead, I want to be, string. Right? I can do something like this. Oh my God. I can do, float. Right? But what I cannot do is so right away, Java kind of tells you print array float is already defined in main. Print array float is already defined in main. So this tells you that there's a repetition of the function because the signature, right? The signature includes the return type. It includes the function name, and it includes the parameter types. Right? So this. So that is what defines a signature. All right. So if I was to go in here and basically maybe add another variable, right? So this will kind of, it will suffice in the rule because the parameters are different. Even though this parameter is the same, there's another parameter in here that is, in here that is different, and therefore it's a different signature. Right? But I can't do something like this because the signature is exactly the same. Okay, so going back. So method overloading will basically allow us to, kind of create the same method with the same name, but have a different parameter. So that way, when we try to print our array, it's going to, it's going to go into the correct function. What I mean by this is, let's look at an example. So let's say create a float array, and I call it my float array is equal to new float. Let's give it some values. I don't know, 1, 2, 3, 4, 5. Right, and I create an int array. oops, my int array, do the same thing. And then let's go to a string array. And let's go the same thing. So one, let's give it different values actually. 6, 7, 8, 9, 10. And my name is Edward. Right. So we know that, I'm kind of doing a fast initialization here where I'm just giving it like the default values. For floats, use the F keyword to kind of cast it into a float. So we know that it's going to be 1.0, 2.0, 3.0, and so on. So let's say I want to print my arrays, right? So print array. So right now, we kind of see that there's 3 functions with, 3 different signatures, and they all return me voids. So they don't return me nothing. So we can see how we can kind of look at this. So our print array, so we have the name of the function. We know what it takes. You can either take an int, a float, or a string. And at the end, on the right side, it's a void where it tells us the return. So if I was to change it to something like this, and I was to do, print array, it changes, changes the return type. So it tells us what it's going to return, which is very useful when you have like a lot of function in your code and you sometimes forget. But I'm going to keep it as void for now. And then I go print array. So now I want to print my float array. So I just put in my float array, and Java will know because this is like an array of floats. It's actually going to use this function. Sorry, this function here, because its type matched the type that we put in, the parameter that we put in here. And we can go through and we can actually see that that's how it works. Print array and then print array, and we do my string array. And in here, what we're gonna do is we're gonna loop it and then print it. My array.length, and then you're gonna S out the print my array at I. And I can go in here and do this. All right, so we see that we're kind of able to do this, and then we also see this code repetition here. Unfortunately, for now, we don't know what we can do about this, but later on, we'll be able to kind of do something different with this that will allow us to maybe create one function to actually just look the array and print it. But for now, with the knowledge that we have, this is okay. Even though we have code repetition for this for loop, it is okay with the knowledge that we have. So I'm going to go ahead and debug this. And because we commented this out, it's only going to run this function. So we're all good to debug. All right, so let's go ahead and get the values for these, right? So we see that, my float is it's an array of floats, we have an array of ints, and then we have an array of strings. So we can go in here, we go to print array and my float array, and we go into it. We see that Java knows to use the right function, right? So we can see how like kind of method overloading helps us. So if I was to step out of this function, you see that it printed all of my numbers. It may not be in the format that I wanted or that I thought it would be, but this is still okay. It's fine. It's not a big deal. We can go in here and it's going to go into this print array. I'm going to step out. It's going to print me my numbers. So 6, 7, 8, 9, 10. And then we can go into here. It's going to step into the string array. And we're going to step out and it's going to print me my name is Edward. And then it's going to go. It's going to finish. And then, it's going to finish executing because there's no more code left. Right. So this is method overloading. So we can see that we can use the same name and give it a different signature, right? So we define a signature by the return type, the function name, and the parameter types. And by using that, we're able to kind of use the same name to do the same thing, but for different types. Later on, as we keep going, or as you keep coding, you probably, you have the same name, but maybe you have another different operation that you do in the function. So you can account for that within the parameters. Yeah, so that's just what I want to say.